Good morning, friends. Today we will be discussing about design, innovation and design-driven innovation for engineering colleges. I am Rohit Swaroop, Chairman, International Innovation and Research Foundation, and this project is about curriculum for engineering students. Now most of you may ask this question, that why do we need design, innovation and design-driven innovation for engineering? We are already studying so much already in engineering colleges, so why add one more subject? So let me share with you this through this presentation today, an in-depth understanding of why we want to incorporate these into our curriculum. Let's look at the slide. Today's session that we will be talking about will be on 21st century and engineers. Design for engineers, innovation for engineers, why and what is design, why and what is innovation, and we will be further looking at why do we need design-driven innovation framework for engineering academic projects. Once we conclude that, we will also be looking at the framework in detail. So let's look at and begin our session. Let me bring in front a quote by Albert Einstein. Let me quote him. "We cannot solve problems by using the same kind of thinking we used when we created them." Now if I was to stop here for a second and come back to the topic of that why do we need design and innovation, this is the basic premises. The problems that we are facing today in our world, those problems come from an era where it originated, that's in the past. And if we were to solve these, we will need newer tools, we will need creative ways and modern ways. So we cannot use the same kind of thinking we used in the past when we created them. This is the premises which we begin with. All engineers are creators, and if engineers are creators, then we need to have a newer way for understanding. Let us look at a root cause. Why do we need, and what is the problem because of which we are talking today about innovation and design for engineers? We have come a long way from agricultural era to industrial to information era. But friends, today we are in an conceptual era. We are in an era where today we need creators, we need entrepreneurs, and we need leaders. If we look into this a little further, what was education in industrial era? In the industrial era, most of the creation and design happened in the West, whereas production and mass production happened in developing nations, that is in countries like India. And therefore, engineers became more as supervisors and technicians. But that is changing very fast, and that's the reason why we need. And why is it changing? So if you look at it, there's a tremendous pressure on each engineering student and professional. Why? Because the industry is asking for scale, scope and speed. All these three S have increased drastically. If you look at it, some years back we only had one car, which was a Fiat car. Today there are hundreds of models that are there. So the scale has gone up. The speed. Today companies require from engineers to come up with new products every 6 months, and the life cycle of the products is also so reduced. So if we look at it, the scale has gone up, the scope is gone up, and the speed, and that is the pressure today on the engineers. So what is the expectation from engineers in the 21st century? If we look at it, these are 4 expectations that industry and professionals have from engineers: problem solving, decision making, original thinking, and entrepreneurial ability. These are the 4 pillars on which engineers in the future have to stand. And therefore, friends, if we look at it on the other side, all my friends, all of you would always have these expectations. So what are the expectations of engineers? Engineers would always look at higher salaries, more challenging job roles, better companies to work with, and national and international careers. Now if on one side the, people are asking for problem solving, decision making, and original thinking. And on the other side, your expectation as engineers is for higher salaries, more challenging jobs, better companies to work with, and international and national careers. So what is the answer? Let's look at what could be the answer. The solution or the answer is that engineers which focused on efficiency and effectiveness are now looking at creation, innovation, invention, and entrepreneurship. If today we can have all of our friends, if today we can contribute not just by learning from books, but learning from real life, so that we could become creators, so we could create, we could do innovation, invention, and entrepreneurship. That's what is the solution today. But how do we achieve that? So if we look at it, here is a small study, and which was done in 2010, and it said engineering students become progressively less innovative over the course of engineering. Now, isn't that interesting? Why would that happen? When we get into the first year, we are more innovative. When we get into the fourth year, it says that we become less innovative. And this was a study that was done and documented. So which means that there is something which is missing and needs to be looked upon. So let's look at the answer now. Let's look at a video which will take us and explain that why and what is the gap. So let's look at this interesting video, and then we'll discuss about that.
Thanks for talking with me, Don. I'm wondering if you might comment on the state of engineering design education today.
Pretty bad. You see, the problem with engineering is that it is deep, narrow, because more and more engineering is a specialty. And when you learn whichever branch, whether it's civil or mechanical or electrical or computer science or anything, you have to learn more and more, in some sense, about less and less, because we've ended up being specialists. We've ended up trying very hard to know much more in detail about the topic and develop formal mathematical models. And that's very good and has led to many advances in knowledge, but in order to apply the knowledge, we don't need narrow, deep. We need broad. We need this kind of education, which spans many disciplines. So spans this discipline and spans this discipline and spans this discipline. So all these narrow and depth are also broad. And that's what the designer brings. Because in order to design something, it's cut across disciplines. It involves people, technology, and not just chemical engineering or mechanical engineering or electronic engineering or it involves all of them. It involves the environment. It's a systems approach. We don't teach that in engineering. We teach specialty. So what we need to do is get people involved in real problems, because real problems cut across the disciplines, and on top of that, that's what engineering should all be about. It's about making technology that's a benefit to people and to society.
So it sounds as though you have some fairly strong views about what's missing. What kinds of skills and perspectives does the 21st century engineer have to have, and how do we educate them in that way?
It's a systems problem, because all problems cut across. And what we really need is a systems approach which takes into account people's real needs, which means probably the social scientists who can go out and study and understand what those real needs are that engineers can help solve. So that involves technology, that involves the manufacturing and distribution, that involves the environment, things that are sustainable, that are sensible, that do not destroy the world. So what the designer is about is the designer is somebody with broad knowledge across these things that can aid the specialists in each of the disciplines. But we need to think of it as a system. And so the engineer of the 21st century has to be a systems thinker.
Thank you for sharing these perspectives with us, Don.
So friends, till now we have been discussing about why do we need design, innovation, and design-driven innovation for engineering. And why I say this, that for engineering it is the most important. Why it is the most important? because engineers are creators. All of you friends there are creators. You are not going to the class to just learn a subject. You are there to apply, because engineering is application of science. So if we are to apply, then we need to have new ideas. And to get new ideas, we need to have newer solutions. That's what we are talking about today. So if you looked at the video, we could understand that what here the gentleman is saying is that we need a systems approach. And what a systems approach is saying, that we need to look at multiple solutions. Being specialist is very good, but along with being specialist, we need to be generalist, cutting across all the disciplines. So talking to your friends in other domains of engineering, be it mechanical, talking to electrical, electronics and civil, to solve a problem of the world. That's what we are talking here, friends. So let's look ahead with and move ahead with the subject. And if we were to look ahead, what is stopping us? If this is the answer, then what do you think is stopping us? So here are some of the reasons that are stopping us. First is that our awareness of the best practices that are there in the world, or what is happening in the world, is missing. Similarly, if we look at unique contextual model. So after we have understood the best practices in the world, the next thing that we need to look at is, do we just copy those models? I don't think so. We need to develop our own original frameworks, our model. Why? Because each engineering college in each city is different. The industry that surrounds you there is different. Each student's aspirations are different. So if that is the reason, that it has to be contextual to a student, to the industry locally, and to the college, to the resources that are available. So we need to have a contextual model. The third point that we talk about is the systems approach. Till now, many of you must have observed that on your own, sometimes you are able to come up with great ideas. But if I was to ask you that you came up with a great idea in the first year, can you repeat that? Can you do it once again? Or can you teach it to the other? Now that's where the problem arises, that we are able to come up with brilliant ideas one time, but because we don't have a systems approach, we are not able to replicate it. So that's the third point. The fourth point that we are talking about is process, techniques and tool. So if I was to tell you today that, okay, here is an approach and here is a method, but if I don't give you the process, the tools and the techniques, then I am leaving you with half knowledge. And that's what happens when we look at the curriculum abroad and we copy something or bring something in which is very good, but is it in our context, and have we got the tools and techniques to do the same? That's where sometimes things go missing. So if we look at the final point, is the opportunity. And when I say opportunity, we have brought everything, the best practices for you, but now we need to give you opportunity. What it means is, along with the tools and techniques, we need to give you a platform on which you apply. What is that platform? That platform is applying whatever you have learned in design and innovation to the subjects that you learn in your classroom, to every subject, and to your academic projects. And if we are able to give you an opportunity where we are able to educate the faculties and the students on what is design, innovation and design driven innovation, then we would have given you the process, the framework and also the tools and techniques. So friends, today we are not just going to talk about that you there have the resources and here is something which I am giving you. We are today talking about why do we need it, and which we have seen why we need design and innovation badly. But it also tells about the second part, understanding the same and applying the same. So let us get into understanding of the topic. The understanding of the topic says that we need a solution, and the solution, after extensive research of almost 10 years, we have come about is design and innovation. And what will be the application? The application is design intervention in the subjects that you study and the framework for academic projects. If we look at these two aspects, let's look ahead. So it is very easy for me to say that you be a design. So the question here is, am I telling you to become a designer? No, I am not telling you to be a designer. An engineer has understood the application of science. Now what I am saying is that you have developed a scientific temperament. What we need now to develop is a design temperament. Why? Because the world we are looking around us today needs application. So just think about it. Why is web technology and internet and mobile applications growing so much? They are growing so much because they are applications. So everybody contributes to developing of product, and then lot of people come into application part of it. Today is an era of application. So what we talk about is that we don't want engineers to be designers. We need engineers to have a scientific temperament, which you already have, and along with that we want to give you design temperament. So that's what we are talking about. Now the question is, what is design? So if we look at it, some people talk about design as a final solution, which is a product, and some talk it also about the process. So friends, we are talking about both the things here, the final solution and the process. That's what design we are talking about. If we talk about innovation, many students get very scared when we say that be innovative or you have to come up with innovation. Please don't worry about innovation. Innovation simply is change. All of us as humans require a change, and periodically we ourselves crave for that change, isn't it? All of us don't just remain same throughout. So we change, and changing things around us is innovation in simple word. So if I was to tell you that if each engineer is a creator, then innovation is coming up with new ideas, creating a product and taking the product to the market. And how do we do that? Let's look at that ahead. Let's look at design approach. Design is basically planned, contextual, creative activity with a